Mr. Young CP Stats, section 1C4. Let's go, guys. Okay, so first let's talk about what a histogram actually is and isn't. A histogram is simply a way for us to display our data where we take all of our data, like if we had a dot plot here, and you see I've got my picture of a dot plot. I'm about to scribble on it. You guys know how I do these things. So I'm going to take everything that's in this section, and that's what's going to basically come over here. So if we counted those, looks like we've got about 18 dots in there. If you want to zoom in and count them, you can, but maybe just trust me. And you'll notice this bar actually goes to about 18 in our histogram. So then if we take the next chunk and notice this bar goes up to 2.0, but it's not actually over 2.0. So that bar's probably just got these two things in it. If you want to count them, you can. It looks like it goes up to about 40. I'm not counting all those teeny tiny little dots. Then we've got this next bar. I think the way they're cutting those up, it looks like it's going to put all of those in it, and that's why it looks almost as high there. So histograms sort of have a different shape than what we often might see if we look at sort of a dot plot or other things. But with our definition, a histogram shows each interval of values as a bar. So think about taking our number line and chopping it up. Here we have a bar that goes from 1.5 to 1.75, then 1.75 to 2.0. So the easiest way to make a histogram is to simply sort things into essentially categories. So to make our actual histogram, we're going to start with some data. And I'm only actually showing us half of the table here. So you can see this table starts at N, Nevada. So we don't have all 50 states here, but this is showing us for each of the second half of the 50 states, the percentage of people in those states that were born in a foreign country. So Wyoming, 3.1% of people, they are residents, but they were foreign born. So what I'm going to do with that Wyoming is I'm going to come over here in these intervals, which we'll talk about how we created these in a second. And I'm going to kind of make a tally. Okay, Wyoming, there's one in the 0 to 5 range. And let's notice here it says 0 to less than 5. 0 to less than 5. Because if you actually had the number 5, 5.0, you would want to put that in the 5 to less than 10 column or interval. So where do we get these intervals? We have these intervals over here. This is where you get to use your own little creative freedom when you make a histogram. You want to look at your data range. Here I can see we go from a low of 1.6. This table goes up to 23, but in the full table, there's clearly something at 25 or above. But you want to come up with intervals that work for your data. This should not be 1, 2, 3, 4. You don't want to have 30 intervals. So the rule of thumb is to have 5 to 15 intervals. Depends on how much data you have. I think 5 to 10 is maybe a little bit better, but if you have a very large data set, sometimes you'll see the textbook use like 15 intervals or something. If you go out of that range of 5 to 15, expect to lose points. So here they jumped by fives, 0 to 5, all the way up to 25 to 30. That gave them 6 intervals and all of their data fit in there. Great. That's what we want to see. So really quickly, let's just look. If we're looking for 0 to 5, you can just go through and count. I'll just circle everything that is 0 to 5, but not including 5.0. I had 6 things. Notice their frequency is actually at 13. That's because we're only looking at half of our table here. I couldn't stick it all on one screen. So we've got 13 things in the 50 states from 0 to 5. So they simply make a rectangle that goes from 0 to 5 and goes up to 13. So those frequency tables that we made last week, same idea, but now we're going to just create a graph out of them. But it's also not just a straight up frequency. We split everything into an interval. Makes a little more sense when we try one. We'll try one in a minute. Before we do, I just want to point out this is not a bar graph. Yes, it has bars, but a bar graph is for categorical data. So we would make a bar graph to talk about eye color, brown eyes, green eyes, right? Those are not numbers. We're sorting people into categories, usually with words. If you have quantitative data, we make a histogram. And notice that the bars touch. The 0 to 5 bar here touches the 5 to 10 bar because there's nothing in between. Right? We go all the way up to, but not including 5, and the next thing does include 5. So looks like a bar graph, but not really. All right, I opted for an example that already had um, a histogram drawn and one that broke the rules. So if you count these, there are many more than 15 bars, right? It's closer to like 30. But they had a sample of 1,640 people. So they had more than enough data that if they make a whole bunch of bars, we get a really good idea of the shape. So I want you to try 1, 2, and 3. This is not going to ask you to um, create the histogram, obviously, because we don't want to make a histogram for 1,640 things, but it will ask you to interpret the histogram, which is important. So give a pause, try this one, and then check your answer. All right, so first up, let's talk about what percentage of people reported spending at least $2,000 on an engagement ring. And then we kind of have to talk about how we arrived at that. So our axis is already in thousands, so here is where 2,000 is. So now we kind of have to look at all these other little bars. That's a lot of bars to add up. So I'm going to do something clever and cheat. Instead, I'm going to look at the bars that are not over 2,000. So there's 150 people there. There's, I'm going to call that 210. This says about what percentage. We are estimating. We do not know exactly. I'm going to call that 215. I don't really care exactly what you call it. We are estimating. And let's call that 260. So let's figure out how many people that was. We're going to add those up, adding on the fly here. So let me try to not make a mistake. I get 835 people that did not spend at least $2,000. So now I can subtract that away from our total. So we're looking at 805 out of 1,640 people who did not. And it says about what percentage. So you can grab a calculator. That's just under 50%. But if we grab the actual calculator and do 805 over 1,640, we'll find that that is 49%. That's my estimate. If you got 48 or something close, fine. I'm going to come back to this answer when we talk about part 3. It asks us to then describe the shape for part 2. Very simply put, if you're paying attention to the dollar sign, without looking at the graph, we should probably guess that this is right skewed or skewed to the right, but it's definitely skewed to the right when we look at the actual graph. We don't even have a tail on the other side. And then for part 3, it wants us to estimate the center and to estimate the variability. So an estimate of variability, we can give our range. I'll start there because I want to talk a little bit more about the center. This is just us practicing what our center and spread. So the range looks like we go up to about 15,000. So I'm just going to call the range $15,000. If you were clever and you noticed that this $2,000 mark was the cutoff for 49% of people, it's almost right in the middle, right? The median is like the bottom 50% and the top 50%. So I am going to call my center estimate $2,000. Doesn't look like it's in the middle of that graph, but it's in the middle. It's sort of our median value, or just about.